What is going on? My name is Derek Jenkins, and today we're going to use a model, and we're going to be able to determine the different bond energies that we're able to find in different carbon-carbon compounds. So, for instance, we're going to have our first model right here, this is going to be a methane molecule. So it's going to be as if the C was in the middle, and it has 4 H's. And so today we're going to look at is if the carbons begin to bond with one another, where will the energy be the highest? So if we were to combine 2 methanes, we will have an ethane. And so pretty much the 2 main different formations that we're going to be looking at will be the eclipsed and will be the offset, which are gauche, depending on which word you want to use. So eclipse is when the molecules are like this, and offset or gauche is when they're like this. So what we want to try to do is we want to try to find out when will this molecule have the most amount of energy. And so if it'll be eclipsed or gauche. And so one way that you're able to find that is the closer that the hydrogens are to one another in this molecule determines how much greater the energy will be. So if we were to try to take a guess as to when the energy will be the highest at eclipsed or gauche, we must be able to see which one has the carbon molecules closest together. So from this, it looks like it might be eclipsed, might have the most amount of energy. But what we're going to do is we're going to test that theory. And how we're going to test that is, if this is true, that no matter how many chains of carbons we have, this will be true for every case scenario. So if we were to add 2 more and turn this into a butane molecule, we'll be able to have it similar, except we have 4 carbons, and then we'll have 10. We'll have 10 hydrogens. So this is what this will look like. So if we want to test it, I would like for you to think about, what do you think will have the most energy, when it's eclipsed or when it's gauche or offset? And so here we can see that it is a significant difference in how close the molecules are, how close the hydrogens are to each other for eclipsed and gauche or offsets. And so you can pretty much use this in any long chain carbon molecule that you may come up against, that for every case scenario, based off of this model, that every time that it is eclipsed, the energy will be greater, and every time that it is gauche or offset, it will be less in energy. Thank you.